When we do a recursive processing, we have to use a common table expression. We learned about the differences between a virtual table created by a common table expression or and the derived table or something similar to a derived table created by a regular subquery. So they look very much alike. For example, both create a virtual table, right? A data set, and the data set is virtual because the data set lives in the computer memory. It does not exist in the database. But there are two significant differences between a virtual table created by a common table expression and a derived table just created by a regular subquery. So number one, if we use a common table expression, our code may look more concise, more streamlined, maybe a little bit more efficient. Number two, if we want to do a recursive processing, we have to use a common table expression. We cannot use a derived table created by just a subquery. Okay, both a derived table and a common table expression both are created by a subquery. They are all based on a subquery, but their behaviors are different. So when we do recursive processing, we need to create a virtual table using a common table expression. I'm going to highlight the virtual table or the common table expression just to take a very high level look at the code. So you look at the code I have just highlighted. This is the definition of the common table expression. When we do the recursive processing, we create a common table expression. Within the common table expression, there are always two data sets. Okay, keep this in mind. It doesn't really matter what use case we are doing with the recursive processing. There are always two data sets. The first data set is here. In the first data set, we have the nodes or we have the records at the top level. Okay, so when we think of the common table expression, when we do the recursive processing, we can think of the virtual table or the common table expression as a graph. Okay, so in a graph, we have a hierarchical structure. So our data is structured as a hierarchy. We have many levels of the hierarchy, many levels in the hierarchy. Some examples are when we do object-oriented programming, right? We are all very familiar with probably Java programming or C++. We have the class library. So we do our inheritance, and the class library is a hierarchy. In the industry, in the real world, we have an organizational structure, right? So within an organization, you have a CEO on top, and then there may be presidents reporting to the CEO, and then VP reporting to the president. And then we have directors, managers, engineers, or other employees. So it's a hierarchy. When we do recursive processing, we work with the data hierarchy. So in our example here, it's the organizational structure. After quiz 1, we will revisit this topic. When we revisit this topic, we will be using a different use case. So we will be working on the, I'm not sure whether you are familiar with bill of materials. So bill of material reports, those are commonly used, very important for the manufacturing sector. So if you want to build a table, you want to build a bike, then you will need components, right? So you have different options. Maybe you can buy components at a very high level, then you just assemble the bike in the factory. Otherwise, you can maybe build some high-level components in-house. For example, you can build something using lower-level components. So simply speaking, bill of materials also represents a hierarchy, similar to what we have here. Just to give you some background info, what we have here is the organizational structure, very, very common in the industry. So when you think of the organizational structure, you know within the organization, you have the top boss, right? The CEO. So let's put aside the board of directors. So we have one person in charge of the organization. That's the chief executive officer, CEO. So in the first data set, we will create the CEO or the top person of the organizational structure. So that's what we are doing in the code I highlighted here. And the second data set is here. In the second data set, we will include or we will find everyone else, okay, like, presidents who report to the CEO and VP, directors, managers, employees, other employees, right? So everyone else will be included in the second data set because we have two data sets, this one and this one. So two data sets, they need to be combined, consolidated into one. We don't want to have isolated data. We want to have a combined, a complete picture of our data. Therefore, we use union all. When we do recursive processing, we have to use union all. Okay, so if you look up the syntax for union, there are some other options. For example, you can just use union without all. But when we do recursive processing, we need to union all, meaning we want to include everything. If there's any duplicate, we need to include that as well. So we use union all to consolidate, combine these two data sets into one, into a single combined data set. So at high level, this is what we have, okay, the structure of our code. And to be more specific, we are using the raw data, which is available on the class server. In case you are interested, you want to play with the code, I want to show you where the database is. So if you go to the class server, you will see, let's see. So if you go to the cloud server, you will see this database. Okay, graph. So you want to experiment with the code, you will need to use this database. And this database is read-only. But you can run the code. You can modify the code to play with it. The data is here. And within the database, we have a table which stores our raw data. It's this one. Okay, so at this time, this is all we need to know about the raw data and the database. When we revisit this topic after quiz 1, we will talk about some other things. Okay, so you will get a more complete picture because we will be talking about graph processing. But since we are talking about SQL joins, and we talked about the SQL joins last week, and this is related to the SQL joins. So I want to make sure we cover this as well. I think we have a question in the message box. So a good question. Union is not, well, I think the behavior is similar. Okay, so the behavior is similar, but it's not the typical join. So union means if you have different data sets, right? You have maybe 2 data sets or 3 data sets, and in your code, when you do a complex processing, you may need to get data from different sources. It's very, very common. So when I was doing the analytics on the Microsoft Global Marketing Operations team, that was very common because some of the data was captured in one system, but there were other types of data captured in other data sources. To be more specific, we had websites, right? And we had the data warehouse, like the enterprise data warehouse, that's Cosmos DB, various websites. So when we ran reports, we created reports, we did analytics, we had to pull data from different sources. So the data that we got from different sources, they all had similar structure. Okay, for example, when you initiate a marketing initiative, you have a marketing campaign, then the campaign or the promotion might be offered at several different places. It might be offered on a website. That's pretty common. It might be offered by sending out emails. That's also very common. Or maybe text messages, right? So you have different ways to launch the promotion, and then different systems will capture the results because you send out the promotion via different systems. Then when the results come back, the results will be stored in different systems as well. Again, could be a website, could be emails, right? Or could be a text messages. So when you want to measure the success, effectiveness of a marketing promotion, you want to make sure you get the complete picture, right? So you want to get the results from your website, get the result from your messaging system or from your email system. So different channels, the results will all have similar format. They all have similar data. They came from different sources. So you run the code to get the results from different systems. Then if you have three different sources, you will have 3 sets of results. And those results, if you do not consolidate them, you will look at one report, for example, the effectiveness, the success of launching the promotion by a website. You have one report, right? And then you have another report for your email system, yet some other reports for other different systems. So you have separate reports or isolated reports, and that doesn't look good. So what we did was we ran similar code, okay, but the code got data from different sources. We ran the code at a central location, and then we put the results from different sources. Then we use union or union. You can use union or union O to combine the results that you have retrieved from different sources. So once you have consolidated, you have combined the results from different sources, then you can create a complete one single report to give the users or the management a complete picture, right? They don't have to look at maybe 3 different separate reports to get a complete picture. They just need to look at one report. If you have all data consolidated into one single repository, you can do more meaningful analytics as well. So that's a typical use case for union or for union role. So if you say, okay, so that's something similar to join, right? Because when we do a join, we put data from different sources. If that's how we think, then that's fine. But literally speaking, unions, or when we use a union or union role, it's not a join, though the behavior is similar to a join. Good question, and thank you for asking that question. Okay, so high level structure of our code is we have 2 data sets, and we are going to combine them into one using union O. So now let's look at the data set more closely. In the first one, we will have the record at the very top level. So if you look at the data here, so I think it helps to look at the raw data. So we are going to look at the raw data here. So you can see we have 21 employees. Okay, I limited the size of the data, so it will not be very cluttered. You can see for each employee, we have employee ID, last name, first name, and then this is the manager's ID. And then the department the employee is in. And we can see everyone has a manager except the CEO, right? The big boss. So number 2, Andrew is the CEO. So Andrew does not have a manager because he's at the very top level. He's the boss. So now go back to our code. We want to select reports to department, employee ID, last name. Okay, so we look at those columns, reports to department, employee ID, last name. They all exist in the original table, the raw data. We are creating this new column because within the organizational structure, in addition to having basic employee information like this column, we also want to know within the organizational structure where an employee is located, right? Whether the employee is the CEO on top, or maybe the employee is a mid-level manager at level 4 or level 5. So we want to know within the organizational structure where an employee is located, because this information is very important. We can use the information to organize our content. So we are creating this new column. So you see the column name. The column name is label. Pay attention to this column. We are creating a new column. The column name is label. And we are starting with 0. So the initial value or the value for the top boss is 0. So 0 is our top label. Okay. And next column is the name, the last name. We want to get the manager's name instead of the manager ID. Keep in mind, the big boss, CEO or angel does not have a manager, right? So when we get the manager ID, manager name for the CEO, we will get a no value because the top boss does not have a manager. So we have this. Okay, but we are using union O. Again, we want to come back to this union. When we do a union O, in our example, we are combining 2 data sets together, but we can combine multiple data sets. There are rules, syntax rules. In our example, we have 2 data sets. So these 2 data sets must have the same number of columns. So if in data set 1, how many columns do we have? We have 1, 2, 3, 4, 5, and 6, right? So we have 6 columns in data set 1. Then in data set 2, we must have the same number of columns. So let's find out. So 1, 2, 3, 4, 5, and 6. This is 1 column, manager name. So each data set must have the same number of columns. That's rule number 1. Rule number 2, the columns must be in the same order. Okay, so let's find out. Let's check that. So the first column is reports to, so that's the manager ID. In set 1, so in set 2, that's also reports to. Second column, department. Second column, department. So the columns must be in the same order. They cannot be in different orders. Rule number 3, the data type, okay, the data type for each pair of columns, for example, reports to in set 1 and the reports to in set 2. So reports to is here, set 1, reports to, that's in set 2. They must have the same data type or a comparable data type. And now probably it starts to make sense to you why we are using this convert. Okay, so in the first data set, the big boss does not have a manager, so manager name will be no. But in order to meet the syntax requirement, each pair of columns must have the same data type or a compatible data type, right? So we want to ensure when we consolidate these two data sets together, we won't have any problem. So we will convert this to Unicode varchar 20. So simply speaking, this column, manager last name, this has Unicode varchar 20 data type here. How do you know this is the data type you need to convert to? Okay, so let me ask the class, how do we know this is the data type we need to convert to? How do we know it? How do we know it? Why is it not varchar 30, for example, right? How do we know it's Unicode varchar 20? So let's do some brainstorming. Okay, you don't have to be exact. So just share your ideas. Okay, so maybe we just create a standardized data type, right? So that's a good thought. Okay. So that's a good thought. Is there any other possibility? Again, we're doing some brainstorming, so you don't have to be exactly right. Okay, so your thoughts, your ideas will help us answer this question. So any thought, any idea is a contribution. We'll go back to this table. This is the raw data, right? So we have, for example, for employee ID number 1, so first name is Nancy. Okay. So Nancy reports to number 3. So Nancy's manager ID is number 3. If we want to get the last name of Nancy's manager, right? We know Nancy's manager has the ID number 3. But if we want the name, the last name, then we just need to go to number 3, right? So number 3, you can see the last name is here. So simply speaking, managers are also employees, right? So because they are all employees of the same company, of the same organization. Managers are also employees. Keep this in mind. So we can go to our table structure. So let's get there. So go to this table. We know managers are also employees. So managers' last name is also an employee's last name, right? So you come here. This is our raw table, raw data, expand columns. You can see the last name is here. So this is the data type. Okay, so this last name exists in the database and it's Unicode varchar 20. And go back to our code. And this is the reason why we want to make sure the last column of both data sets will have Unicode varchar 20. Okay, so just the details we need to be familiar with. And we are getting the raw data from this table, org hierarchy. That's the table we just look at, because we want to include only the top boss, the CEO, in the first data set. And the CEO does not have a manager, right? So the manager ID is no. So this data set will give us the big boss. Again, we go back to our original table. So you look at the data here. Which employee will be included in the first data set? Just to give you a hint, there's only one employee, right? One big boss in the organization, one CEO in the organization. And that CEO, that big boss, will be included in the first data set. Who is that big boss? Look at the data here. Excellent, right? So Andrew Fuller. So Andrew Fuller will be included in the first data set. And you pay attention to reports 2. The big boss does not have a manager. So this column has no value. And go back to our code. We say where reports 2 is no, right? So I think we are clear with the first data set. So we went over all of the details. Now we are ready to include everyone else. So everyone else will be in the second data set. Again, we have reports 2, that's in the database, department, that's in the database, employee ID, there, last name, there. And pay attention to this label +1. Okay, so label is the new column we are creating. So we know within the organizational structure where an employee is located. When we do the recursive processing, we process a graph. Okay, so an organizational structure is a graph. We will process employees or records at a level at a time. So each time when we traverse the graph, when we go through the organizational structure, we will be working with employees at the same level. So for each iteration, we will work with employees at the same level. For example, we started with level 1. Okay, but we numbered level 1 as 0. So our top level, technically speaking, is 0. So we started with level 0. Then we will be going down to level 1. And once we are done with level 1, for the next iteration, we will be working with employees at the next lower level, that's level 2. So when we go through each iteration, we will increase level by 1. So this is what we are doing here. Level +1, very important. And the very last column is the manager's name, right? We don't want to just display the manager ID. We want the manager's name. So therefore, we have this self-join. Select last name from org hierarchy. Where this employee ID Okay, so EMP, so this is the org hierarchy here, equals E dot reports to. So E is here, another copy of the same table, org hierarchy. So this is something similar to a self-join, but we are doing a correlated subquery. So we are using this correlated subquery to get the manager's name. Okay, we don't want to just display the manager ID. Names are more descriptive. And that's the reason why we want to make sure we have the correct data type, right? Okay, so you look at these columns, 1, 2, 3, 4, 5, 6. They match the columns in the first data set. Now, let's pay attention to the from clause. So we are selecting from org hierarchy, right? So that's our raw data, our table in the database. Inner join, direct reports. So I asked about this, but just a refresher. What is direct reports? What is direct reports? I'm scrolling up and down so you can see the code, right? Because there's more code to fit in one screen. And look at the join here. We are doing an inner join. We're joining org hierarchy with direct reports. We know org hierarchy, that's our table, right? Our table in the database. What is this direct reports? CTE, right? Very, very good. The name of the CTE, common table expression. So direct reports is here. We are joining the common table expression to itself for each and every iteration. This is where the recursion takes place. Okay, the recursive processing takes place here. So pay attention to this inner join. And we join on common columns. So employees manager ID equals manager's employee ID, right? Because employees are managers are employees, and all employees are stored in the same table. So this is the second data set. The second data set has everyone else. So first data set, we have the CEO, the big boss. In the second data set, we have everyone else. Then we use union all to combine them to have just one single consolidated data set. Once we have the complete organizational structure, and that's defined in the common table expression, then we can use the organizational structure to do whatever we need to do, right? So here we just select some columns. So select employee ID, last name, department, label, reports to, and so on and so forth. You can do all sorts of processing here. You can join the common table expression to other tables. Okay, so it really depends on your use case, because once you have the organizational structure, the graph in the common table expression, it's just like a regular table. And you can join that table to any other table or tables to meet your logic requirement. So now let's run the code. You can see we created a new column, this label. And this new column indicates where within the organizational structure an employee is located, right? All other columns exist in our database, in our original table. Okay, so we went over the recursive processing, spending more time, and I think we covered all the details that we have thought of. Are we clear on this? Does anyone have any question on this? This is very interesting. Okay, so if you go out to do data work, you will see this type of processing in the industry, pretty common, usually advanced, relatively advanced. So are we clear on this? Does anyone have any question? Any other question? Okay, good question. Why is the data grouped by department? So let's look at the code. We say order by department, right? Because we ask SQL to order the employees by department. So we can change this by, what else can we order by? Let's see. We can order by maybe just what would be a good employee ID? Okay, let's do that. Order by employee ID. And run it. Now you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So it's just the regular SQL query. Once we have created the organizational structure, it's just a table. So we can use the table to do joins, to do whatever other types of processing we need, or we can sort the data anyway we need to. Good question. Okay, thank you. Any other question?
Can I ask a quick question?
Sure, yeah, go ahead, please.
So before you put the employee ID, so you put department and then level and then last name, like in order by?
Yeah.
So if you do that, so you just do the department first, and then, so it seems like it's just order by department only. So is that?
Let's run the code, we'll find out, okay? So
Okay.
let's run the code again. So we say department label and the last name, right? So come here, we have, Big Boss doesn't have a department, so let's, don't worry about him. Finance, right? So we say department and then label. You see 1, 2, 3, 4, 5, 6. You know what I'm saying?
Yeah,
so, yeah, it did the sorting according to according to our code. So we told SQL, okay, sort the returned data first by department, then by label. For employees at the same level, then we want to sort by what? So sort by last name, right? So you can see, for example, finance, there are 2 employees at the level 4 last name. Well, they all have the same last name, so not a good example. So let's look at another one. So look at IT, still the same. I think that's the manager. Manager ID, I'm sorry, I need to look at the employee ID. Okay, so employee ID, employee names are more distinctive. So let's see, what do we sort by? Last name. So last name is which last name? So let's see. So we have last name. Last name is employee name. So last name is here.
It seems like just
Okay.
employee L name is the
Exactly. You see this column. So last name, right? So last name is just employee's last name. Now go back to our data. So you can see in finance, there are 2 employees at level 2. And then the last names are King and this Suyama, right? So K comes before S. So this is the alphabetical order. So we can sort by any number of columns, and the SQL will just do whatever we need SQL to do. Good question. Thank you. Yeah, we're not limited to just one column. Good discussion. Any other question, please? Are we all clear? Okay, if we are all clear, I want to move on. If you think of a question later, okay, please just bring it up.